Rational expressions can be multiplied and divided. In this video, we're going to look at specifically multiplying and how to simplify rational expressions. When we're looking at multiplying rational expressions, we need to first talk about how to simplify rational expressions. So the big thing with simplification is you're going to have to factor. So I'm telling you now, factoring is the key. So you're going to have to use the AC factoring. Because of time restraints, I'm going to go through this a little bit quickly with the AC factoring. So if I have x plus 4 over x squared minus 16, the bottom there needs to be factored. So with that being said, like I said, I'm going to go through this a little bit quicker. The factorization of x squared minus 16 is really x plus 4 times x minus 4. So with that, you guys can see that the numerator and the denominator share a same factor. Because they share a same factor, this x plus 4 can cancel out. Therefore, we are left with 1 over x minus 4, where x cannot equal 4. And the reason why x can't equal 4 is because we can't divide by 0 in the denominator, have that 0 in the denominator. So that is my simplification with a rational expression. Now, sometimes you'll be given a different type of rational expression that's not in factored form. So for instance, 3x cubed y6 over 10x squared times 4x to the 5th y to the 7th over 9x squared y10. Looking at this, this is pretty much rules of exponents. Going back on that, just a refresher, when you're multiplying, you're really adding your exponents, and then when you divide the exponents, you're really subtracting. So if I'm looking at this, I'm going to go ahead and simplify it so it's one expression together, then simplify it down. So 3 times 4 gives me the 12. On top, I have x to the 8th, y to the 13, divided by 90, x to the 4th, y to the 10. So when I'm looking at this, I can go ahead and simplify, my coefficient numbers and then my x's and y's based on their exponents. And again, division is really subtraction of those exponents. Looking at the 12 and the 90, they both have a 6 in common. So this actually goes down to 2 over 15. If I'm subtracting, 8 minus 4 gives me to the 4th, so that goes in the numerator. And then the 13 minus 10 gives me a 3, which goes in the numerator as well. So that right there is my simplification of a rational expression if it's not in terms of like a polynomial or factorization. So simplifying, again, using the factorization, trying to figure out how to cross out or cancel different factors. But let's talk about actually multiplying these. So let's say that I have x squared x minus 4 over x minus 3 times x squared plus 3x minus 18 over x cubed. So whenever you see a polynomial and it's not in factored form, you're going to have to get it into factored form. So noticing here, the only expression that's not in factored form is this guy. So we're going to have to use AC factoring in order to simplify that down to the factors. Again, because of time restraints, I'm just going to do it quickly. This is going to be x plus 6, x minus 3 over x cubed. So when I'm looking at this, I see some things that can cancel out right away. So this x minus 3 is gone. The other thing I notice is the x cubed and the x squared. They can simplify down in terms of my expression like the last example. So the x squared is going to cancel. The x cubed is going to just turn into just a regular x to the first. And it's going to stay in the denominator there. So now I can rewrite this as my factored expression. X minus 4 times x plus 6 over x. And looking at this, x cannot equal 0 in my domain. So again, you're going to be using that AC factoring over and over again. If you need a refresher on it, you better go watch the video on the AC factoring just so that this can go a little bit quicker for you. We'll discuss in class maybe some tricks of the trade to help you get through that factorization quickly. But otherwise, this is going to be our multiplying of rational expressions.